So we have our first results from our first manually segmented subsegmental heart. And so what I have here on the screen is the LV. And what I'm going to do is I want to review the results of this manual segmentation of the automated blood pool. I'm sorry, the manual subsegmentation is what we're reviewing, and I want to review what we need to do in order to prepare the first sort of test of the subsegment. And then we'll do a quick QA of the subsegmentation itself. So the main purpose as we look at this LV here is to see how well do we think the sort of the mesh matching over time will perform. And so if we're first focusing on the body of the left ventricle rather than the left ventricular outflow tract or the inflow region of the mitral valve, I think this looks as good as we can hope for. If I pause it and here I'll start at 1. As we go through it, this is a papillary muscle cavity, as is this, and so those exist in all of these cases, and I would hope those would preserve. As we go through, let's see. So if we go out to end diastole, I can still see the papillaries you can kind of still see how there's a gap that runs up in there. So those are the trabeculations. So I'm hopeful that those will be preserved in this analysis. And really this is about as good as we're gonna, like, this is pretty good. We need to make sure that our solution covers that. Now that this is a much more simpler result, but I want to see how it performs. And so again, my hope is that this could do fairly well with that. So now let's discuss. Well, let's talk about, do we need to do anything with the LVOT here? And so if I go back to 1, just so we start same spot, playing it through, we can see that there is some variability. One thing I will note is that the method by which we're cutting out this looks pretty good. We had 2 different people performing segmentations, and they were random, so we kind of got a good sense of how well that performs by sort of teaching the same method across both people. And say here in diastole, it's it's pretty much the same. There's definitely a chance that and again, since these were random, we don't know which is which, but for example, in this one, they could have cut a little lower here, and that would have made that one seem more in line with the others. And then during in Sicily, this one looks like a little too much was taken out, but given sort of the ratty nature of this, I wonder if that specific model wasn't looking too good, and even this one may have been an initial early attempt, because there's also some failure there. And again, here, this one is way different than the others. And again, I can see where I could take out some there, all the way down to here, and here. And again, I think what we need to do is we need to pick some sort of an angle. If we say that this is the plane is right here, a 45 would kind of take us from this point up. So if I'm going to cut, like, 45 would cut about like that. It may be a 30 degrees, maybe, but we probably need to pick an angle and then create some education that trains specifically that how to do that. I mean, we are going to have to eyeball it in the training, in the manual segmentation, but I think there's a chance that a 30-degree cut along those lines will get us where we need to be. And see here in 4, let me go back to 4. This looks like maybe like 15. This may be a little too shallow. I mean, it's almost like, and again, this one probably could have come down here. It's hard to say without, it's maybe a slightly too shallow, but it's close. It's not too bad. This 3 could have used some work. Too steep. And again, 1, this just, it doesn't look like it was cut the way we were wanting to, that way we're doing that. And so some of this we will improve upon as we do this. This one looks pretty good. Like this is, I think, and we're in diastole here, and we can see that like this one looks pretty good. And if this one had this section, had this cut out and that down further, I think this one and this one would have been pretty close. So this one, it looks like it was, and again, see how this is lumpy? I think this is one where the cut was made where the actual valve was rather than that 3D method. But because this one looks so close to how these are looking here, I think that confirms that the way our sort of cheat code for doing that is pretty good. And again, this is just for subsegmental. 17, that's too steep of an angle, especially right here, the way that's cut. So I think maybe between 45 and 30 degrees. If people can visualize 30 degrees, I think that'd be better. If it's a hard thing to conceptualize when you're cutting it, then we can choose 45 for just being an easier method. Now, if we turn our attention to the mitral, and again, the mitral should have been cut out from the, let me zoom in here. The mitral should have been cut out from the right atrium, actually. And so this is sort of how it's scooped out. I think fixing stuff like this, that's an obvious little fix. This one looks pretty good right there. That looks very good. Honestly, except for that one, those all look, ooh, look at this one. This looks about as perfect as possible. Look how, this is probably right along the lines of the mitral, and we're in diastole, so it's not closed. The aortic valve's closed. But those look great. So most of these mitrals cutting off the RA are fantastic. This is one where it probably could have been done a little better. That is just beautiful. Some of those are pretty good, except for some of this extra stuff over here. I think 8 had it too. Yeah. So I think, so for the purposes of, let's first discuss, we're going to apply the method to this. I would choose one of these guys that looks pretty good as your starting point, because we know that, so pick a starting point where you like the mitral and you like the aorta, and see how it looks starting in end systole and then finding a good one in end diastole, and see how those look. If we find that this part up here is too jagged and it's jumping too much in the process, which it may not, but it may, then we may need to come along, and for the purposes of this first trial, I would not be opposed to finding the smallest angle and just doing a straight cut on all of them at the same spot for the purposes of this specific project of the mesh matching project. So for mesh matching, first step, I would pick a starting point and end systole that you like, where the aortic and mitral are a good averaged, nice look, and end diastole, good aortic and mitral valve, and see how those look. If we find that those errors are causing problems on the big on the main file, then we may have to go in and manually cut those and fix those so there's less variability for the mesh matching step. Now let's move into final little quality assessment. So I'm going to turn back on. That's the left atrium. I'm just going to turn them all on for the purposes of this. Ooh. That is. Okay, so now press play on this. And I can already pick out a couple problems. The pulmonary valve location is probably going to be the same thing as we saw with the aortic valve. It's just we can't see it. So this is what that looks like up here. And we'll solve for that. I think seeing how there's variability here, I think learning where that cutoff is. So if we pause here, so this is the SVC. Oh, did I just land on one that? Yeah, so for some reason, 5. Oh, well, this is something. I think there was one where the right atrium did not turn out well and did not segment well, and so that's probably why this one is like that. As I go through here, you can see how where this cutoff sort of fluctuates. Honestly, I like this one here. And as I play it, look at the SVC coming in to the right atrium and look for the morphologic change in the vena cava compared to the atria. See how you can kind of see this? This is the right atrial appendage where it comes off. I can continually sort of see that cut playing here. So that would be something to keep in mind going forward. And if we apply that, I think the IVC is in a good spot. Like I think this is a good location. It's fairly consistent. The only thing different is whether or not there's contrast that is parked down in there. The other part that required analysis here is this left atrial appendage. When I was first looking at it, here it has been identified as pulmonary veins as opposed to the atrial appendage. So if you can see that, see how the appendage was cut off on 19 and 20. And there you can see like this is actually, I don't know why that snuck through, but as you go through, again, here's 14. Those are all. And then 1, it also, see how 1 is. So 1 and then several at the end. I think for purposes of since we're creating the database, I'm okay with, for editing our database, to let the LV ride as is. For the database, we may need to go in and if the RV wasn't showing up, I don't know why I can still see it, So I don't know why this wasn't. Maybe this is just a oversight because it's here. So it should be, that should be fixed for the training data set. But I do think the left atrial appendage, we need to fix those. So going back in and fixing those is going to be important. So for before we park this and say it's ready to be part of the training, we need to fix the atrial appendage and the right atrium. And if we find that we don't have, and then I think, okay, we can leave the LVOT and the mitral stuff for training. I think we'll have enough as we get better at that. The error will average out. So, all in all, this is fantastic work. Keep it up, and this is the beginning of something pretty awesome. As I'm playing through this, let's look at the right atrial, right ventricular border here. I think what we learned on the LV border, we should apply here also. I think it looks pretty darn good. There may be opportunity there, but in fact, let's just get rid of the blood pool. So press play. There. Yeah, I think that's fairly consistent. There's obviously, now I know that there were some where the contrast was not very good, and I bet that's what we're seeing in some of this. But I think the borders for the tricuspid valve are actually, I think the methodology is working very well. And if we look at the, I think the pulmonary artery, I think it actually looks better than on overall than the aorta. And I think probably the only difference is probably angle. Like that looks a little steep right there. This one, obviously, that one's a little wonky. If I put the peripheral back on, yeah, see how I can see that it was a little, that may have been early case. But I think the pulmonary valve, again here, yeah, we can see how those may have been some of the early ones. I think those will get averaged out, and we don't need to go chase that down before putting these into the library. But I do like this one here. This looks pretty good. I like 2. And I liked 2 on the other one too, also. So anyway, this is great work. Thank you.